Namaskar, dear learners. I am Dr. Shweta Tripathi from School of Engineering and Technology, IGNOU, New Delhi. Today, in this session, we are going to discuss about our course Energy Management, MRW004. In our previous sessions, we have discussed about energy conservation, energy audit equipments, etc. And now in today's session, we are going to discuss about thermal energy utilization or thermal energy management, in which we will be discussing about thermodynamics today. So as we all know that thermodynamics is very, very, very important. Why? Because when we talk about thermal energy management, it is very important that we should know that in which form thermal energy is coming, how we are utilizing it, and how much waste is there. In our previous sessions, we have discussed that for an efficient energy management, we have to do an accounting of how much energy is coming there, that is energy input, how much energy output we are getting from it, and how much loss is there. So this is that we have to understand for managing energy or for the proper energy management. So in this regard, when we talk about the thermal energy, that how much thermal energy is coming, how much is converted into work, and how much is wasted, to account thermal energy, basically we need to learn about the thermodynamics. So if we talk about thermodynamics, what is thermodynamics? As we know that thermodynamics, thermo means heat, and dynamics means anything which is in motion. So generally this thermodynamics is the study of the effect of work, heat and energy on a system. So what happens generally, the work is done by the system and heat is required by the system, or some heat is lost by the system, or sometimes the work is done on the system. So there are two things. One is work done on the system and another is work done by the system or through the system. Similarly, heat enters into the system and heat is coming out from the system. So this is what we have to account for thermal energy management, and when we learn about these things, we call it as thermodynamics. So basically in thermodynamics, we will check it out, or we will account the amount of heat that is either transferred to the system or transferred from the system, or the work which is done on the system or work done by the system, and an internal energy, whatever internal energy is there in the system. So this internal energy is basically potential energy or kinetic energy or some other form of energy, all together will be there in the form of internal energy generally. So in thermodynamics we will learn all these things. Now there are two kinds of thermodynamics. Generally in thermodynamics we deal with the macroscopic changes and observations. Okay, so generally we don't go for the atomic level study, but when we will study about the when we will study thermodynamics of the atoms or molecules or in the microscopic, we will call it statistical thermodynamics, because here the bulk properties will be in the terms of constituent atoms and we will treat them as the aggregation of atoms, okay, not the behavior of any individual atom. When we talk about classical thermodynamics, it concerns with the relationship between bulk properties of matter. Here nothing will be examined at the atomic or molecular level. So this is the basic difference between classical and statistical thermodynamics. But in our course, in this energy management, we will be discussing basically on the macroscopic properties. So if we talk about the thermodynamics, it is very important to learn about the basic terminologies that we are going to use in the thermodynamics. So first thing is system. So what is system? System means anything. If you are going to analyze something, we call it as system, and there is a certain boundary. This boundary can be either real or imaginary. So we make a boundary. Why we make boundary? Just to separate that thing, that where we have to focus, that is known as system. And whatever is beyond the boundary is known as surrounding. So the control volume or the substance about which we are talking, we will call it as a system. So generally it is defined as the part of universe that is selected for our study or the thermodynamic consideration. That is, we will study about the effect of the various properties of this system. And what are these properties? These properties are basically temperature, pressure, volume, etc. So on the basis of these changes, that how much pressure variation is there, how much temperature variation is there, how much volume variation is there, depending upon these things, we decide that how much work has been done or how much heat is wasted there. So basically we have to observe the change in these properties like pressure, temperature, volume, etc. So whatever thing that we are focusing on is known as system, and whatever thing apart from that system or after the real or imaginary boundary that we are making to identify that system from the rest of the universe is known as the surrounding. So two things are there. One is on which we are focusing, that is we are considering that the properties will be changing, that is known as system, and anything apart from the system is known as surrounding. And in thermodynamics, we generally learn that how much heat is transferred to the system or how much heat is transferred from the system to the surrounding. Or we will see that how much work is done on the system or how much work is done by the system. And depending upon these, we will see that or we will say that how much work has been done and how much heat is lost there. So that is what we are going to discuss today. Now if we classify the system on the basis of heat and mass exchange, because when we talk about the thermodynamics, heat could be exchanged and mass could be exchanged also from the system to the surrounding. Exchange between system and surrounding generally we are talking about. So there are three kinds of system: closed system, open system and isolated system. If we talk about the closed system, generally what happens? Here the mass where heat and work can cross the boundary, but here mass will not cross the boundary. So that is a closed system. Only heat is allowed to go outside the boundary, or only heat can go to the surrounding from the system. So these kind of systems are known as closed system or fixed system, fixed mass system. Why? Because here mass transfer will not take place, only heat transfer will take place and work transfer can take place. So there is only the exchange of energy with surroundings. The exchange of mass will not take place in this kind of. For example, if we see that a water is placed in a vessel or hot tea is placed in a teapot, then what happens? After some time that tea becomes cold. Why? Because the heat is transferred from that thing. We all know that heat is transferred from higher temperature to lower temperature. So generally when you will keep some hot substance for hot tea in a flask, what will happen? After sometimes it will in a teapot, what will happen? After some times it will be cold. So heat transfer was there, so it has been cold. But you will see that if you have put 1 liter of tea there, the tea will remain same. That is 1 liter of tea will be there after some time also. So here mass transfer is not taking place, only heat transfer is taking place. Another system is open system. So as the name says, it is an open system. So here in the boundary, mass will also transfer. So in case of open system, both heat and mass transfer can take place. For example, when you heat something and when you are heating water in a container, what happens? The water is evaporated. After some time, you will say that water is heated also, and the amount is lesser. That what was initially the amount that was there is now less. So here heat and mass both are transferred. Then comes the isolated system. In isolated system, there is no exchange. There is neither the exchange of mass nor the exchange of heat takes place. So here no exchange takes place, neither heat nor mass. So generally, when water is placed in a vessel which is closed and is insulated as well, then what happens is, suppose we keep tea in a flask. What happens? Tea remains warm for some time. So why it is like that? Because heat transfer is also not taking place and mass transfer is also not taking place. So this is the isolated system where heat is also not taking place. So generally, for making isolated systems, we have to make use of insulation, etc., so that the conduction of heat or anything could not take place. So this is about the types of system on the basis of heat and mass exchange. So open system, closed system and isolated system. Now if we talk about the any thermodynamic system, how are we going to define any thermodynamic system? So generally, if we define any thermodynamic system, we use certain properties to define that particular system. Suppose I say that this is a glass of water and I am treating it as a system. Then I had to tell about the pressure, temperature, volume, entropy and heat of that particular system. So these are some of the quantities, some of the thermodynamic properties on the basis of which we express any thermodynamic system. Temperature, internal energy, entropy, heat, volume, etc. we can give. Now, if we give volume, on the basis of that, we can calculate internal energy or entropy. So these quantities are generally defined when we go in the detail of thermodynamics. Now, there are generally 3 laws of thermodynamics, and first, second and third law, and a 0th law also. In our course, we are generally going to deal with the first law, second law and 0th law. So the first law of thermodynamics, I remember that my teacher used to say that the first law of thermodynamics says that you can't win. Why he used to say so? What is basically the first law of thermodynamics? You all know about the law of conservation of energy. And what is it? It is the energy can neither be created nor destroyed. It can only be transformed from one form to another. So generally, you cannot create energy on your own. Whatever energy is available in the nature, you have to transform that energy into some useful work or useful form of the energy. So generally, the conversion of energy takes place. We are not going to create any energy, and there is no anything is available in the atmosphere or in the environment that will absorb all the energy that is available. So you cannot destroy energy also. So this is why we say that you cannot win. So if we talk about the first law of thermodynamics, it says that it is an extension of this law of conservation of energy. And we can say that here, if we talk about the mathematical form, generally we say that whatever heat is transferred there is equal to the work done by the system. So generally, if we talk about the change in internal energy of any system, we say that it is equal to the heat that is added to the system minus the work done by the system. Here, sign convention is very, very, very important. So if heat is added to the system, it will be positive. And if heat is extracted from the system, it will be negative. Similarly, if work is done by the system, it is negative. And if work is done by the system, it is positive, and if work done is on the system, then it will be negative. So here if we say about the change in internal energy, so generally change in internal energy is equal to Q minus W, where Q is the heat transfer and minus W is the work transfer. So you have to check it out that how much heat is extracted from the system and how much heat is supplied to the system. Similarly, for the work case also, you have to check it out that how much work is done on the system and how much work is done by the system. So from here your first law of energy comes. So from here you will check it out that how much loss is there also. Okay, so this is about the first law of thermodynamics. Now if we see this picture, you can see that there are two systems. One is at state 1 and one is at state 2. Here at state 1, pressure, temperature and volume is there. Okay, some different pressure, volume and temperature is there, and for state 2 some different pressure, volume and temperature will be there. Okay, now if we say that if both of these systems are in equilibrium, equilibrium is the state, whatever state, both will possess similar state, so there will be no variation, then the system will be in equilibrium. So if we say that any thermodynamic system which is at equilibrium, it possesses a state variable, and we call that state variable as internal energy. And between any two equilibrium states, there is the change in internal energy. So some change in internal energy will be there, because it is going from state 1 to state 2. So whenever the state will change, okay, internal energy will be changed. So here the change in internal energy will be E2 minus E1. E2 is internal energy of state 2 and E1 is internal energy of state 1. So what will happen here? Here E2 minus E1 will be equal to the difference of the heat transfer into the system. Here you can see that heat is transferred from one system to another. So difference of the heat transfer into the system and work done by the system. So here E2 minus E1 will be equal to Q minus W. So this is the first law of thermodynamics. Now depending upon these change in state, we can define various processes also. So there are generally four kinds of process on the basis of which we define any system: isobaric process, isochoric process, isothermal process and adiabatic process. So when we talk about isochoric process, in this process what happens? It is a constant volume process. That means when the system is moving from state 1 to state 2, the volume will not change. So this kind of process is known as isochoric process. Second one is isobaric process. So as the isobar, bar means pressure. So isobaric process. So here pressure will be the constant. So when we have two systems of two states, 1 to state 2, so here the volume of the system will not, pressure of the system will not be changed in case of isobaric process. Then is the isothermal process. Isothermal process is the process, the change in internal energy is taking place at constant temperature. So here as thermal means temperature. So for isothermal, constant temperature. So generally iso means constant and thermal means temperature, baric means pressure and choric means volume. Now comes the adiabatic process. So in this kind of adiabatic process, heat transfer will not take place. So this is important terms from the point of view of the various processes that takes place. So whenever there is a process or change from stage 1 to stage 2, these process will be there. Any one of these processes will be there. And when more number of processes will be there, there could be a cycle also. Okay. The processes could be cyclic or non-cyclic depending upon our application. Now if we talk about the work done of all these processes, so let us first discuss about the adiabatic process. As we know that if we talk about the first law of thermodynamics, what was it? It was delta E or delta U is equal to Q minus W. U is also internal energy and E is also internal energy. So delta U is equal to Q minus W. And now when we talk about the adiabatic process, we know that in adiabatic process there will be no heat transfer. No heat transfer means Q is equal to 0. So we can say that here always internal energy is equal to minus W. So it means when a system will expand adiabatically, W is positive, that means the system does work. So our delta U will be negative. And similarly, when a system compresses adiabatically, what will happen? W will be negative. That is, work done is on the system. So here delta U will be positive, because minus W we will keep there. So minus minus will be positive. So delta U is equal to W. So delta U in that case will be positive. So this is about the work done or change in internal energy of adiabatic process in terms of the work done. If we talk about isothermal process, so we know that in isothermal process temperature will be constant. So when we are talking about delta U is equal to Q minus W, what will happen here? W will be there, and for Q what we have to do that? For ideal gases generally delta T is 0. So if delta T is 0, it means the internal energy is 0. So here in case of isothermal process, Q is equal to W. It means the energy that is entering into the system in the form of heat will leave as work. So if any energy is entering in the system as Q, it must leave as work, that is W. So for isothermal processes, Q will be W. So what will happen here? Any heat flow into or out of the system must be slow enough to maintain the thermal equilibrium in case of isothermal process. Then comes the isobaric process, and we know that in isobaric process we have constant pressure. So here if we talk about delta U, W and Q, all are not zero. But when we are going to calculate it about ideal gas, we will get that W will be equal to P into delta V, and here delta V is change in volume. So change in volume is available here and P is constant. So our W will be, W is equal to P dot delta V. So our delta U will be W minus Q minus W, that is Q minus P delta V. So if we talk about the example of this kind of process, it is when we are boiling water in any saucepan, etc., then it is a isobaric process. Then comes the isochoric process. In isochoric process, as we have discussed, that for isochoric process we have constant volume. So when we talk about the W is PdV, always pressure into displacement. So displacement is change in volume. So here as volume is constant, so dV will be 0. If dV is 0, that means PdV is 0. Okay, P into dV is 0. So what will happen? W will be 0. So here W is 0, then your delta U will be equal to Q. So we can say that it is heating in a closed container. Whenever we are heating anything in a closed container, it is always a isochoric process. And here when the volume of a system doesn't change, it will not do any work on its surroundings. So W is 0 here, and internal energy will be equal to the heat transfer that is taking place in this particular process. Now let us discuss about the heat capacity of this system, because heat capacity is important, because on the basis of this heat capacity we will calculate the amount of heat transfer. We know that how much work is done there by PdV, that is the displacement of the piston, work done by displacement of a piston. Now if we talk about the heat capacity, how we are going to calculate Q? So basically the amount of heat that is required to raise a certain mass of a material by a particular temperature, that is called heat capacity. Now let us say that the material is raised by delta T temperature and mass of that matter is M. So the amount of heat that is required to raise the temperature to delta T will be mc delta T. And here this C is known as the specific heat of substance. And when we have constant pressure process, we will take this constant specific heat of substance at Cp. And when we are talking about the constant volume process, we will take this specific heat as Cv. So when we talk about the constant pressure process, Q will be mCp dt. And when we will be talking about the constant volume process, it will be mCv dt. So these are two things that you have to keep in your mind while checking for this Q. And how you will decide that whether the work is done on the system, the heat is transferred to the system or heat is transferred by the system, it will depend upon the condition that is provided to you. So generally heat capacity is CV, Cp. Generally this CV is 3 by 2R. R is universal gas constant and its value is 8.314 joule per mole Kelvin. And if we talk about Cp, it is 5 by 2R. So this is how you have to give the value of Cv and Cp, and on the basis of that you have to calculate Q. For constant volume it will be mCv delta T, and generally it is equal to delta U. And when we will talk about constant pressure process, it will be mCp dt, and that will be equal to change in enthalpy. So this is the basics of the thermodynamics that we have learned today. We have learned about the first law of thermodynamics. We have learned about the system, how we are going to identify the system. We have learned about the four important processes: isobaric process, isochoric process, isothermal process, and adiabatic process. We have also learned that how we are going to write the equation of first law of thermodynamics for all these processes. We have calculated Q and W for all these processes. I hope you have understood all the things very well. In our next session, we will be discussing about second law of thermodynamics, and we'll learn more about heat transfer through the system and heat engines as well. Thank you very much for watching us. Thank you very much. You can reach to me and ask your doubt in your Google Meet class also, and by email also. Thank you very much for listening carefully. Namaskar.